All right, let's go ahead and quickly look at the topic of momentum. First of all, we have defined momentum as any object or anything that has a mass and velocity. We say has momentum. So anything that has momentum is basically an object that has mass and velocity. All right. Now the unit of momentum is kilograms per meters per second, and later on you'll see why that is the case when I give you the formula for it. And it is also considered to be a vector quantity. Now, in most problems that we deal with at the high school physics level, we're dealing with horizontal momentum, and we're not really concerned with momentum in the y-axis, which could be due to, for example, the gravitational field of that planet, specifically Earth. Now, you can find the momentum of an object by simply multiplying the mass of the object and the velocity or the speed of the object. It's important to remember that the unit of momentum is simply a derivation of the units of the quantities used or the variables used inside the formula of momentum. We know that mass is measured in kilograms and it's getting multiplied by velocity, which has a unit of meters per second. That's why the unit of momentum is simply kilograms meter per second. Now, one important thing to remember and understand is about basically the conservation of momentum. And conservation of momentum, just like conservation of energy, is a simple law that is discovering or sort of like referring to the fact that something doesn't change. So when we're talking about conservation of momentum, what we're really saying is the momentum at the beginning of an interaction, whether it's two things hitting each other or two things hitting each other and then sticking to each other, for example, a bullet going into a person and a person flying off, is actually the same. So the momentum at this initial at the beginning of the interaction is going to be the same as the momentum at the final stage of the interaction. So conservation of momentum has a very simple formula, and that's simply that the change in momentum, or you can say sigma momentum initial, or pi, is simply equal to sigma momentum final. That means that the sum of the momentums at the beginning of the accident or kind of like collision is going to be the same as the sum of the momentums at the end of the collision. And so what that means is that the total momentum is going to be conserved. Now, there's different cases of conservation of momentum. We define them as either elastic, we call them elastic collisions, or inelastic collisions. In elastic collisions, the total kinetic energy of the objects is going to be kind of conserved. It's usually for when two objects kind of hit each other and then they get separated. So imagine you have a ball or tennis ball that hits another ball. This is ball number 1 and this is ball number 2. They kind of hit each other, and then once they hit each other, or maybe the second ball is actually at rest, for example, ball number 2 is at rest and then ball number 1 is moving with a velocity of 3 meters per second. When this ball hits the second ball, they're going to hit each other and then eventually get separated. So ball number 1 moves in its own direction, ball number 2 moves in its own direction as well. In such a case, we can calculate the momentum of both these balls by simply saying that the initial momentum, or P number 1, I, plus the initial momentum of the second ball is going to be equal to the momentum of both of them at the final stage. Because if they hit each other, they're going to be moving with a specific speed. We can call that final velocity. So this is going to be equal to P2 initial plus P2 final. That is going to be their momentums of them at the stage where they get separated from each other. In inelastic collisions, however, the two objects actually hit each other and they are going to get not separated instead, but rather stick to each other. So if two objects were to hit each other and actually stick to each other, they are going to carry the same mass and they're going to have one final speed. So imagine a tackler that is, catching a quarterback midair. They're both going to fall down with the same speed and their masses get added. So in that scenario, you can say the initial momentum of the person that is tackling plus the initial momentum of the the quarterback itself, is going to be equal to the masses of both of them. So their momentums are going to get added technically. And so you can say the mass of the tackler plus the mass of the person that is running the quarterback is going to get added, multiplied by one final speed. So they both will have the same momentum because they stick to each other. Now, to give you a better idea, let me give you an example. Imagine we have the same thing that I was just talking about, an example of inelastic momentum. You have the tackler that is moving with an initial mass of, let's say, 50 kilograms. And the speed that he's moving at is 5 meters per second, and that's a relatively low mass for a tackler. But let's assume we have not a chunky tackler, and then we have another, for example, a quarterback that has a mass of like 20 kilograms. This is probably like the NFL for like the kids version, so just assume the masses are really small. Now the mass of the quarterback is 20 kilograms, and the velocity that he's moving at is like perhaps 6 meters per second. Now, let's say they collide at some point in the field, and the quarterback is going to be tackled by the tackler, which was 50 kilograms. So what's going to happen is you can find the final velocity of the tackler and the quarterback in the air by simply combining their masses. So the mass 1 and 2, that's going to be the mass of both of them. What's 20 plus 50? That's 70 kilograms. You can now find the final velocity of them. So you can say the momentum before their collision is simply equal to the momentum after their collision. So you can say M1 V1 or P1I, initial momentum of the first tackler, is going to be added to the momentum of the second person, which is the quarterback, is going to be M2 V2, is going to be equal to the masses of both of them combined, or M1 2, multiplied by the velocity of both of them, or V both. So M1 is simply 50, V1 is 5, and this is going to get added to 20 times 6 because that's the speed of the quarterback, and this will be equal to the masses of them both combined, which is 70, multiplied by their velocity. So you can find the velocity of both of them after the tackle simply by dividing both sides by 70, and that would give you, 50 times 5 is 225. So 225 is going to get added to, let me do that real quick, 250 is going to get added to 6 times 20, which is 120. So 120 gets divided by the 70, and the answer is 5.28 meters per second. So that's going to be the velocity of both the tackler and the quarterback, because they kind of fall down since the tackler is going to hug him and kind of like push him to the ground so that he can stop running. Now, this was one example of inelastic collision, and it's really important that you can distinguish between elastic and inelastic collisions. So in elastic collisions, the objects get separated, but in inelastic collision, the objects stick to each other. So, for example, another example of an elastic collision would be a cannon that is firing a cannonball, and an example of inelastic collision would be perhaps a footballer kicking a football too hard and the ball kind of sticks with his leg as it's moving, or perhaps a dancer that is catching another dancer on the ice rink. So, dancer catching another dancer. Let's go ahead now, take a look at another example of conservation of momentum. This time, you go ahead and give it a try before I do. If you can, that's great. Check your final answer. If you can't, watch the rest of the video to learn how to do it. So, let's say a 2 kilogram cart is moving right at 5 meters per second on a frictionless track. And it collides with a 3 kilogram cart initially at rest, So the 2 kilogram cart has a final speed of 1 meters per second to the left. What does the question want from us? It wants the final speed. What is the final speed? What is the final speed? I forgot the there, but imagine it's there. What is the final speed of the 3 kilogram cart? All right. So shout out to Khan Academy, by the way. I got this question from them. It's a really interesting question. You see it in a lot of physics books that are kind of investigating the topic of momentum. So here's what you have to do. The thing is that the 2 kilogram cart is moving to the right and it has 5 meters per second of speed. So you can say 2 multiplied by 5, that's the momentum of the cart. And keep in mind, the momentum of the cart is the mass of the cart multiplied by the velocity of the cart. So I'm just going to call that VC. And that's going to get added to the momentum of the other cart that is initially at rest. So its mass multiplied by its speed, which is 0. And this will be equal to the, keep in mind that the 2 carts are hitting each other and getting separated. And so, because one of them is moving to the left. So what is going to happen is the momentum at the end, or final momentums of both of them, are going to get added. So this is P1F plus P2F, and P1F is the mass of the first cart, which is 2, and it's moving to the left with negative 1 meters per second, while what we're looking for is the final speed of the other cart, which has 3 kilograms of mass, and its final velocity is unknown. A lot of students also tend to forget the fact that this is moving to the left. That's why we have negative 1 meters per second. Make sure you put that there, otherwise you're going to get a completely different answer. Now, what's going to happen is you get 10 over here equal to negative 2 plus 3 times the final velocity. If you bring this 2 to the left side, you get 12 is equal to 3 times final velocity. So the final velocity of the other cart is going to be 12 divided by 3, which is 4 meters per second. And that's it. That's going to be the speed of the cart as it moves to the right or left, but we cannot know what exactly is the direction right now. But since it's positive, we can say it's going to the right. And usually, if they ask you to find the magnitude of velocity, you just have to take the absolute value of the number, and the magnitude is going to be 4 meters per second. Keep in mind, whenever they say magnitude of something, they don't want the direction. So you have to take the absolute value, which makes the final value a positive number. So, overall review of what we learned that momentum is simply mass times velocity. That's the first thing we learned. The second thing we learned is that momentum is conserved in a collision or an interaction between two things that are colliding, causing an accident or something. And so we can say the momentum before a collision is always equal to the momentum after the collision. And if we were to add these two things up, we would get 0 technically, just like conservation of energy, momentum, or angular momentum. The third thing we need to know is that for situations where the collision is elastic, the two objects we said separate, the objects get separated. And so you can find the elastic collision formula by saying M1V1 plus M2V2 is equal to M1 V1 prime, M2 V2 prime. And by V2 prime and V1 prime, I just mean the final velocity of the two objects. So these are just VFs, or final velocities. This is the formula for elastic collision. And last but not least, if they're undergoing inelastic collision, then the two objects stick to each other. So objects stick to each other. And we can say that M1 V1 plus M2 V2 is equal to M1 plus M2 times the velocity of both the objects. And keep in mind, in both the situations, the momentum before and after the collision is conserved. However, in elastic collisions, the total kinetic energy is also conserved. But in inelastic collisions, the total kinetic energy is not conserved. Total kinetic energy is not conserved. And that's because the two objects stick to each other and they get a different mass, and they also have a different velocity. And because of that, the kinetic energy at the beginning and the end is not going to be equal. Thank you for watching this video. Best of luck and take care.